So today we're going to talk about solving equations that contain radicals. So the first step whenever you solve an equation that has a radical in it is you want to get that radical completely by itself. So in example number 1 here, we're going to move the 3 over first so that we can get that radical on one side with no other extra numbers or variables or anything. So we have the square root of 2t minus 1, that's all under the radical, equals 3 because we add the 3 to both sides. Now, in order to get rid of the radical, we can square both sides. Remember, you can do an operation to one side as long as you do it to this other side as well. So we can square both sides of the equation, and when we do that, the square and the square root, they're inverse functions, so both of those just disappear. So we end up with the 2t minus 1 equals 3 squared, which is 9. And then you just solve this like a regular algebra equation, or algebraic equation. So you add the 1 over, and then divide both sides by 2. So t equals 5. And then you can check your answer by plugging it back into the original equation. So we have the square root of 2 times 5 minus 1 minus 3 equals 0. So 2 times 5 gives you 10. 10 minus 1 is 9. So you have the square root of 9 minus 3 equals 0. Square root of 9 is 3, and 3 minus 3 is 0. So we know we're correct. Alright, so let's take a look at example number 2. We already have our radical by itself, so we don't need to move anything over. So now we're just going to square both sides. And when we do that, the radical is gone, so we're just left with 7x minus 12 equals x squared. And then we want to move everything over to one side. I prefer to keep my x squared positive, so I'm going to move my 7x and my 12. All right, and now we can go ahead and factor this in order to solve. So remember, each set of parentheses gets an x to begin with, and then we look at the factors of 12 that will add up to give us a negative 7. Well, we know we need to have both negatives because the only way to get a negative in the middle with a positive constant is to have two negatives. And then the factors of 12 that are going to give us 7 are 3 and 4. So then we take each of those and set them equal to 0. Oops. It needs to be x minus 4. So x equals 3 and 4. And then we can solve that by plugging it back into the original equation. So we have the square root of 7. Let's move that up a little. Alright, square root of 7, what was the original problem? 7 times 3 minus 12 equals, that should be 3. 3. Alright, so the square root of 21 minus 12 equals 3. And 21 minus 12 is 9. And the square root of 9 is 3, so that works. Now let's try the 4. So 7 times 4 under the radical. So square root of 7 times 4 minus 12 equals 3. So square root of 28 minus 12 equals 3. Oh, not 3, that should be a 4. This should be 4s. Sorry about that. Alright, so then you have 28 minus 12, which gives you 16, and the square root of 16 is 4. That's not a V, that's a check mark. Alright, so we know that we're good for these. Alright, so let's take a look at example number 3. We have several things going on here on the left-hand side, and we need to get that radical by itself. So first we're going to add the x over to the other side. Okay, so we just add the x over to the other side. Then we're going to divide both sides by 3. Okay? So now we have the radical by itself. And now we're going to square both sides. I don't know why I just wrote cube. All right, so we're squaring both sides. So then that becomes x plus 1 and then when we square this, it becomes 1 plus x times 1 plus x, and then 3 squared is 9. Okay? So now in order to get rid of the fractions, we can multiply everything by 9. So we're going to multiply this by 9, and we'll multiply this by 9. Okay? And then that brings us here, where we have 9x plus 9, and then these 9s are going to cancel out, so let's just show that, and then we can multiply this out, and we get x squared plus 2x plus 1, okay? And now we can just get everything over to one side, so 2x minus 9x is negative 7x, and 1 minus 9 is negative 8. And then we need to factor. Both get an x, and we need 1 plus, 1 minus, because that's a negative, that 8 is negative. Okay? And so we look at the factors of 8 that will give us 7. Well, 8 and 1 will give us a negative 7, and we need the 8 to be negative in order for that 7 to be negative. And so we have x plus 1 and x minus 8. So then we just set them equal to 0. So x equals negative 1 and 8, and then we check them. So we plugged in the negative 1, and so here we get 3 times the square root of 0 plus 1, because minus and negative equals 1. Square root of 0 is just 0, so this disappears, and 1 does equal 1. So that one's good. So negative 1 is good. Now let's check the 8. So we do 3, then we have 8 plus 1 minus, I guess I don't really need that parenthesis there, 8 equals 1. That's an equal sign. All right, so 8 plus 1 is 9. And then square root of 9 is 3. 3 times 3 is 9. And 9 minus 8 is 1, so that one's good too. So we checked both of those. They both work. So our answer is x equals negative 1 and positive 8. All right, now let's try the last one.